All right, guys, let's start talking a little bit about Pythagorean theorem. We are taking this up a notch from just your a squared plus b squared equals c squared and finding a missing side. What we need to remember first is just simply we've got our two legs that are going to be a and b, and then our hypotenuse is always across from the 90-degree angle, and it's going to be the letter C, always our longest leg. And we have our formula right here as well as right here for us. So let's go ahead and kick right into it here with number one. Okay, I'm going to draw that line from my 90-degree angle to figure out where my hypotenuse is, C. This is the one I am missing. So with my formula, my a squared plus b squared equals c squared. A and b does not matter. Your legs, it does not matter which one's a and which one's b. So I'll have 3 squared plus 4 squared equals c squared. 3 squared gives me 9, plus 4 squared gives me 16. Good idea to have these memorized. Is going to equal c squared. I add the two numbers together. I'm going to get 25 equals c squared. You are not done. We have been working with radicals this entire time, this entire unit, because we have c squared is 25. So we need to find the square root so that we can cancel that square here. And what you're going to find out is this is going to be a perfect square, and c is going to equal 5. And if you went through and did the division tower or the factor tree, you go, okay, 25. Can't divide it by 2, can't divide it by 3. I can divide it by 5, and I get 5. Well, I have a pair, and I have nobody to stay inside the house. So when you have all pairs, you have a perfect square. Okay? Next, we're going to add in this radical. All right? So let's talk about this. We're going to wind up, again, here, find our c. c is going to be that 6th square root of 2. So with my formula, I'm not going to rewrite it, but when I'm missing a leg, I always like to leave a squared there, so my variable's in the front, plus 6 squared is all going to be equal to, putting this in parentheses, 6 square root of 2 squared. We come down here, we say, okay, a squared plus 6 squared is 36, and this is going to be equal to, well, when we square a number, we need to remember that we have to factor that square to both the whole number and the radical. So here we square the 6 whole number, and we're going to get 36. We're going to multiply it by, well, the square and the square root are going to cancel each other out, leaving you just with the 2. So we're going to have multiply it by 2. So a squared plus 36 is going to be equal to 72. Last step, this time we are subtracting. We're going to subtract that 36 from both sides. On our last step, but a squared is going to equal 36. Now our last step, square root, both sides. 36 is going to be another perfect square of 6. All right, take a look at the next problem. We have here a trapezoid. Okay, remember from our unit with the with our quadrilaterals. But we're looking for the slant on the trapezoid. So let's make this a triangle. Okay? Here, we can tell this would be a rectangle over here. So these two sides are the same. So here we have 8. And down here, to find that missing piece of the triangle, the missing leg, all we need to do is take that 11 total. We're going to take away that 5, because these two sides are congruent. We're going to take away that 5. So we do 11 minus 5, we're going to get 6. So that's this side right here. So again, with our Pythagorean theorem, here's our 90-degree angle, giving us our hypotenuse, C, is what we're missing. So I'm going to take 6 squared plus 8 squared, because those are my legs that I have, all equal to C squared. 6 squared gives me 36, plus 8 squared is 64 equals C squared. Add these two together, we're going to get 100 equals c squared. Need to make sure, square root, the very, very last thing we do with Pythagorean theorem, this is going to be another perfect square of 10. Plug these radicals into the calculator. If they come out to a whole number, it's a perfect square. If they don't come out to a whole number, that's when you need to go back and simplify. Now, on number 4, we have this square. We're going to talk more next week on what's going to happen here with that diagonal and what's actually going on. But for right now, we just need to focus on one of these triangles here. We have a square. We know that because we have 90-degree angles and because all four sides are the same. So what that means is this side up here, this leg, is also going to be x. So we know that this is also going to be a 90-degree angle. So here's C. So we don't have A or B, but it's okay. They're exactly the same thing. So here we could just do x squared plus x squared is equal to the C squared right here of 5 square root of 2 squared. Over here we have 2x squareds. They are exactly the same, so we can combine them into 2x squared. Now we need to do our factor or our distribution here. We're going to square that 5, giving me 25. We're going to multiply it by that square cancels the radical, leaving you just with the 2. So we have 2x squared is equal to 50. Now, we haven't seen a whole lot of this with the 2x squared, with that coefficient in front of this x squared, but that coefficient is the last thing we take care of. So we're going to divide both sides by 2 to get rid of the coefficient, and we're going to get x equals 25. Sorry, x squared. See, I'm making a mistake. You can make a mistake too, so be careful. X squared equals 25. We take the square root of both sides to get rid of that square. And we see here, we already have this one, square root of 25 was a perfect square. X is going to be equal to 5. The next section is asking us to determine if we have Pythagorean triples. When you have triples, these are patterns, these are numbers that anytime you see two of the numbers, two of the legs, if you know the triples by heart, then you can automatically know that third side. Okay, let's go ahead and figure this out first, and then I'll explain a little bit more in a second. So what we're going to do is we're going to use this a squared plus b squared equals c squared and find out if a squared plus b squared equals c squared. Find the biggest number. This is going to be c. So we have 5 squared plus 12 squared is going to equal 13 squared, if this is a triple. So we have 5 squared, 25, plus 12 squared, 144, equals 13 squared, 169. When we add 25 plus 144, we're going to find out we get 169. So this is going to be equal, we do have a triple here. Every time that you have a leg that's 5 and another leg that's 12, your hypotenuse is automatically 13. Done. Okay? Or if I have a hypotenuse of 13 and a leg of 12, I know the other leg is 5. Your triples are really, really good to get to know also. So if you see a triple, you can just write triple as your work and write in the answer. The next problem here, find C, the biggest number, right here. So we have 9 squared plus 12 squared. Let's find out if this equals 15 squared. Here we get 81. Plus 12 squared is 144, equal to 15 squared is 225. 81 plus 144 will give you 225. And we do have another triple here. This triple is actually a 3, 4, 5 triple. What we have done here is we have a 3, 4, 5 triple. And what we have done is we have multiplied all of these by 3. Take this by 3, we get the 9. The 4 by 3 is 12. The 5 by 3 gives me 15. So it actually originated as the easiest triple to remember, the 3, 4, 5. Take a look at example number 1. 3, 4. And as you recognize, a leg is 3, a leg is 4. You could put x equals 5 and just write the word triple. You don't have to go through all of this. That's the great thing about knowing your triples. Next, we have 24, 25, and 7. So find the biggest number, 25. This is C. So we have 7 squared plus 24 squared equals 25 squared. 7 squared gives me 49 plus 24 squared gives me 576. 25 squared is 625. We add these two together, we're going to get 625. So we have another triple here. And this is not a multiple like B was. Okay? So your most common triples to memorize are going to be your 3, 4, 5, your 5, 12, 13. So we can write these up here. We have our 3, 4, 5. We have our 5, 12, 13, 7, 24, 25. The reason these are the easiest to memorize is because, well, 3, 4, 5, done, right? 5, and then you have 12, 13 consecutive numbers right here. Same thing here. You have 7, and you have 24, 25. Look at the shortest number, 3, 5, 7. You just jump in two numbers, your odd numbers, 3 to 5 to 7. And you remember 3 goes with 4, 5. 5 goes with 12, 13. 7 goes with 24, 25, another set of consecutive numbers. So these are some good triples to remember so that we do not have to, go through and simplify and, work through all this stuff. We could just go, hey, it's a triple. I got this one memorized, guys. So the next problem here is we're looking at the converse of the Pythagorean theorem. This means instead of saying, a squared plus b squared, let's find a missing side. Now I'm going to give you all the sides, and you have to tell me if it is a right triangle. Guys, we just did that. That is exactly what we did right here. We looked at our triples. This is exactly what we're going to do here, okay? We're going to find our biggest number to represent B and C. So with these radicals, what you want to do is plug it into the calculator to figure out what you're going to get so that you can figure out which is the biggest number. Is the radical the biggest number or not? In the case of letter A here, the square root of 13 is going to be the largest number, so we'll act this as C. So we're just going to do that 7 squared plus 8 squared equals, in parentheses, because we have that radical, the square root of 113 squared. 7 squared gives me 49. 8 squared gives me 64. Again, the square cancels out that radical sign, leaving you just with 113. When we add 49 and 64 together, we're going to find out this comes out to 113. So a squared plus b squared does equal c squared. So, yep, we have a right triangle there. So we can go ahead and put our little right triangle sign here. Look at the next one. We go ahead and plug in all of our numbers, or the 4 square root of 95. Find out if it is bigger or smaller than the 36. It's going to end up being bigger. So we're going to use this as our C. And we start going through and solving. So we'll do 15 squared plus 36 squared is equal to, parentheses, because we have a radical, 4 square root of 95 squared. 15 squared is going to give me 225. 36 squared, probably not one we've got memorized. It's going to be 1,296. And then when we take this next one, we've got to distribute the square to the 4, giving us 4 squared is 16 times that 2 cancels out, the square cancels out the radical sign, giving you just the 95. So 16 times 95. So we have 225 plus 1,296, all equal to 16 times 95 is going to give you 1,520. When you add 225 plus 1,296, you're going to get 1,521. We are going to see these are not equal. Make sure you put that not equal sign in between those two numbers. Okay? So because these are not equal, we will say, no, this is not a right triangle. Do not go draw a 90-degree right angle right here because it is not a right triangle. The last two problems we have here are going to be word problems. Best to draw some sort of picture so we represent our triangle. To help support a flagpole, so I know I'm going to have a flagpole. Okay, here's my little flag. A 50-foot long tether is tied to the pole at a point 40 feet above the ground. So wherever that is tied, let's say it's up here, okay, it's 40 feet high. Okay, that 40 feet above the ground tells us that's going to be our vertical distance. The tether is then pulled taut, it's tied to the anchor on the ground. So let's say here's our little anchor. So that tether is going to go from the top of the flagpole down to this anchor. Okay, so here's the tether. We were told that it was 50 feet long, so this one's 50 feet. We want to know how far away the base of the pole is to the anchor. Okay, so here's your base of the pole. We want to know the horizontal distance right here. Your flagpole and your ground will always make that 90-degree angle. So what ends up happening here is across that 90-degree angle, the tether is going to be C. So we're looking for a leg. So here we have x squared plus 40 squared is equal to 50 squared. So bring this down. 40 squared is going to be 1,600, 1,600. 50 squared is going to give me 2,500. Now, because we have that adding to the x, we now need to subtract. When we're looking for a leg, we square the numbers and then subtract. These cancel. We get x squared is equal to 2,500 minus 1,600 is going to give you 900. We square root these to get rid of the square on the x, and 900 is going to end up being another perfect square, giving me 30. So the base of the flagpole is 30 feet from that anchor. Our next problem here, we have a 20-foot ramp. Well, number one, a ramp is always going to be the diagonal. It's going to end up being the hypotenuse. So here I'm going to draw my picture. This is going to be my ramp. And we're told that it is 20 feet. So this side is 20. It's used at a loading dock. Okay, so let's say here's our loading dock right here. Scoot it over a little bit. All right here, this is our dock. If the base of the ramp, okay, here is the base of the ramp, is placed 8 feet from the base of the dock. Here's your base of the dock. So this base of the ramp is placed 8 feet right here from the base of the ramp, from the base of the dock. We want to know how high is the loading dock. So we want to know that vertical distance right here. Okay? Again, this dock and the ground right here is going to be forming that 90-degree angle, letting us know that here the ramp, 20, is going to be C. So again, we're looking for a leg. So we go through, we say, okay, x squared plus our other leg, 8 squared, is equal to 20 squared. Bring this down, 8 squared is 64. 20 squared is going to give me 400. We need to subtract that 64 from both sides. So these cancel. X squared is going to give us a total of 336. I would tell you right now, 336 is not a perfect square, which I'm glad this is in the notes because we need to remember sometimes we are going to have to simplify that radical. So let's take a look at 336. I'm going to do the division tower here. I'm going to take 336, always start with the smallest prime number 2. Divide by 2 until you cannot divide by 2 anymore. We divide by 2, we're going to get 168. We divide by 2 again, we're going to get 84. Divide by 2 again, we're going to get 42. Keep dividing by that 2 until you can't anymore. Oh, here we go. We get 21. Now we can no longer divide by 2. Move to the next smallest prime number, 3. Can we divide it by 3? We can. We divide by 3. We're going to get 7. And we see that we are at the top of the tower with a prime number. So let's go ahead. X is going to be equal to, let's figure out our partners. Here we've got a pair of 2's. I have another pair of 2's. These will stay outside the house. 3 and 7 do not have a partner, so they're going to stay in the radical house. Everything outside we multiply, everything inside we multiply. So we're going to end up with 4 square root of 21. There's our final answer.